Okay. Good morning again. Good morning, everyone. From our previous videos, we are talking about normally distribution data, how it look like, and so on. And we generated some data, again, some data which are normally distributed, and graphically, we see how normal distributed data can look like, and also numerically. And you can see even those tests and so on and so on. Okay. Another point I want to remind is this golden rule, the one I'm calling it golden rule because it's safe in many situations. When you know how it's working, you are safe, and you know many things. Statistics, the rule of p-value. The rule of p-value is saying that when p-value is less than 5%, we are rejecting our null hypothesis, which one we call also H naught. But when your p-value is greater than 5%, we are accepting or we are failing to reject the H naught. Yeah, and now we are considering the H naught, the null hypothesis. Okay, we have what we are calling null hypothesis or H naught, and you have alternative hypothesis. When we are rejecting null hypothesis, we are taking now alternative hypothesis. But when we are failing or we are accepting H naught, then we are rejecting null hypothesis. And all tests you have to do, statistical tests or numerical tests, those p-value things will come, and you will make your conclusion according to them. For this reason, I'm saying that if you get right the interpretation of p-value, you know how it's working. You know how it's working. You know the rule of p-value. It's like you have already have part of statistics, because always when doing tests, when doing regression, it will come, and the conclusion is based on it. Can you see what is happening? Then it's very, 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 very important. As I'm just saying, we are talking about normal distribution, but in that case, we are talking about normal distribution when we were generating normal distribution data. Then from here, let's say that we are making some regression, for example, and the way we want to check our normal distribution. As I'm telling you, even to run a linear regression, simple, one condition also is the data should be normally distributed, for example. Then we need to check and see what is happening, because everywhere, like even when we are talking about probit, the error of data should be normally before to use probit. Many models are based on them, but we have also some rules which are coming to say when we have many observations, yeah, we can also not be focused on normal distribution things. Yeah, many observations mean that we have more than 30 and so on. Okay, but we need really to understand what's normal distribution things and so on. Okay, then from here we will be learning how to do linear regression, and now how to check now on normal distribution things. Linear regression. Okay, linear regression. Now let's call it linear regression model or linear model. When I have something like the commands LM, and now before to run linear regression, we know our dependent variable should be numerical or quantitative. From our previous video, we talked about what is qualitative and quantitative data. Yeah, that is. Then dependent variable is what, like let's say that we are growing maize and we have yield. Okay, our yield can be dependent variable, and now the quantity of fertilizer and the hours of work we put on this farm can be what we are calling dependent variables. What we are bringing to obtain something, what we are obtaining is dependent variable, in this case yield. Okay, and the yield depends on the quantity of fertilizer we used, and also how we maintain our farm, the number of hours we work on our farms. Can you see? Those one are controlling the yield. Okay, then yield is just there, and it depends on those variables, how we did them. This for this is called dependent variable. And what is independent variable? Independent variable is those one which are bringing change on dependent variable. Okay, that is, then in our case, the example I have just given is like yield dependent variable. Numbers how we put in work, in our farm, and also the quantity of fertilizer we put can just called independent variable. Now I'm just trying to explain it because now I'm saying that to run linear model one, we need our dependent variable to be quantitative. Yeah. Then we need first to understand what is quantitative data. It's already explained in our previous video. Those one which can be measured. They are numbers. Okay. And now what is now dependent variables? What I have just now explained. And now we need to see again here the data we are using is data which one. We need to see from our data what is quantitative and use it as dependent variable. Here can you see education or experience here, for example. Wage even is numerical one. Okay, let us use wage and saying that our wage, what we are obtaining as wage depends on what? Experience, education first. And now experience we have. But in real life, it's understandable, it's okay. The wage of someone can depend on the education he is having and the experience he had. Then things like that. And now, which data we are using? The data we are using here is wage one. Okay, and I can have it here. Then from here, to get right what the result of my linear model is saying, I have to use summary, for example, and now call it linear model. Okay, then let me run this one, control enter, run it, and now the summary now is, yeah, I'm running also the summary. Okay, they're telling me something, unexpected value. What is it? Linear model is run, is okay. Okay, no, I didn't run even the linear model. It was not coming. I should run it first. So after running it, now I can have the summary. Okay, and can you see it's giving me the results and whatever I have here, just like I have the result which is coming. Then we have things like that. The purpose of this video is just to show when you are just running linear model, how to check on normal distribution things. Then we will not go in the interpretation of this result. The next video will come and interpret the result, how to interpret the results of of linear model when we have it like that. Okay, another things I forgot to show you from the previous video is when you have already your plot, yeah, have already your plot and you want to delete it. Maybe you are finished to do whatever you want to do. You want to delete it. Is this command which is used dev.off, and now we can run. You can see that I cleaned my graph. Okay, now we have run this model. We want to check if those data used to run this model are normally distributed and so on. We want to see this kind of things. And now from it now, let's say that we can use the residual of errors. Yeah, we can use the residual of error of the model to do this checking things and so on. Okay, there are many ways to go, but let's proceed like that with the residual of what? Of this linear model. Let us use it first and come to have like, I have my residual of this model. Okay, running it now. Okay, that's okay. Or maybe I can call it like, let me call it f, giving it f as values, then let me assign it f. If I assign f like that, then I have what I'm calling residual of my model. And now I can check. I have many, we have learned how to check those normal distribution thing, visualization, or also we can use graph. Yes, visualization. We can check with our eyes, running a graph and check. We can also use numerical checking. Okay, then let's say I have also already this data there. and I can use first of all histograms and yeah, and have what is happening here. Okay, F is what I assign to my residual I generated, yes. And now let's see what is happening. You can see what is happening here. I can have histogram, and from what we did in I think video 2, 3, we explained what is the normal distribution and how it can look like, and when you are visualizing your data, how you can make conclusion. I was saying that when you have a graph like histogram, whatever is at the left is the same thing as at the right. You have at that moment normal distribution. And basically is what I said. And here can you see we have many things there which are totally different from when we are moving to the left. Okay. From the experienced eyes, this data is not normally distributed. It's okay like that. Then here we use histogram. We can use also QQ norm and QQ line as we used when we are talking about normal distribution above. If it's not very clear, you can go and check video 2 or 3 where we talk about normal distribution. There we give more explanation and detail on normal distribution data and so on. And I hope, okay, we can proceed again with this one, this kind of things. Okay. Yes, we can proceed. QQ norm now. And now this one alone cannot allow us to say something. We can add QQ line. Okay. And from QQ line, we can say these kind of things. Okay. But now, can you see? Okay, the conclusion of this one is like normally data is not normal distribution. Data is the one which is coming. Let me give them colors, and now it will help us really to see. Let's give the first one the color blue, and now the second one we can give it red. Okay, then running this one, we have blue. Run this one, we have red. Yeah. I didn't put color before. Can you see? Okay, this one is the reference, the line. Okay, when data, this one in blue is just around of the red one, we can see that data is normally distributed. But when sometimes we have some data very far from the red one, you have problem. There is a normal distribution there. And you see it started very well, but at some points it's very far from the red line. And we are saying that it's not normally distributed. Okay, let's also check using numerical tests, because those one can come and just confirm numerical test now. Okay, let's use a Shapiro test. Okay, first of all, using Shapiro and the Lilly test, we need our package which is called NOR test, because we have already loaded it here. There is no problem. We can proceed with the test. Shapiro test coming and using F. Yeah. I have the result. Okay, from the Shapiro test or whatever the normal distribution test, as we said previously, yeah, the H note is the null hypothesis is data is normal distributed. You can see this what we said just above. Data is normal distributed when we are using those normal distribution tests. Okay, now it's the result which is coming to confirm or to reject the H note. When we did our Shapiro test, we can see the p-value is 2.2 times exponent minus 16. That means that it's very far from 0.000002. data now p-value is less than 5%. We are doing what? We are rejecting our H-naught, okay? And H-naught was supposed to be or is what? The H-naught is not data normal distributed. We are rejecting it. Then when we are rejecting the null hypothesis, we are taking alternative hypothesis, which is saying that data is not normal distributed. That is, okay? Then our not numerical test is confirming what we got from the visualization. Yeah, and also we can use also Lilly test. Huh? Okay, can we say that from the literature Shapiro test is widely used, but we can use others also. Then here Lilly test also is a normal distribution test, and now let's us run it and see. Okay, and we got also this. Okay, the p-value also is less than 5%. And now we are rejecting our H-naught and making conclusion that data is not normally distributed. Okay, then I got sometimes some questions saying that we are expecting to have p-value the same everywhere. Okay, in this case it's okay everywhere from Shapiro test or Lilly test is the same, but you can see the p-value is just different. But what is matter is what the conclusion is saying. We cannot, for example, have p-value less than 5% from the first test and the p-value greater than 5% in the second test. If things like that happen, that means that there is a problem. Okay, we can have the value which are just different. We can have the value which is are just different everywhere, but we have to conclude to have the same conclusion, how to reach the same conclusion. Okay, that is what is happening when you have your model like linear model where one condition is data should be normally distributed. You can check how to check on normal distribution here. Then from here we learn how to run linear regression model and how also to check on normal distribution data. Thank you so much. And this one is video number 5. From video number 6, we can go and learn how to do some tests, statistical tests, and so on. Like for talking about t-test, yes, chi-square test, Fisher test, and so on. Then make your time to watch the next video number 6. Thank you so much for your time.